In previous sections, we have looked at how to solve systems of equations in which we had x and y and or x, y, and z, two equations and two unknowns, three equations and three unknowns. In this particular section, we're going to look at doing the same kind of thing, but now we have equations that have degrees greater than 1. In other words, we might look at something that has an x squared or a y squared in the equation. We still have the main two methods that we have used before, substitution and elimination. But the bottom line really is we're going to try to figure out how to take, in this case, our two equations and solve. And in a similar fashion to what we had before, since we've got a line in this case, and this would be a parabola, instead of just having one point where they could intersect, we might have a couple of points where they can intersect. Now, it's also possible that they could still intersect at one point if it's what's called a tangent. Or, in other words, the point of intersection is the vertex of the parabola and the straight line. Or we could, of course, have no solution because the entire line is either below the vertex if it opens upward or above the vertex if it opens, the parabola opens downward. So that's what this section is about, is how to solve these particular problems. So let's look at our example real quick. We have x squared plus 3xy plus y squared equals 22, and x squared minus xy plus y squared equals 6. We can use elimination on this to get rid of the xy terms. And note that all we had left was the xy. We got rid of the x squareds, we got rid of the y squareds, and all we had left was an xy. Now, you might say, well, how does that help? But what we can now do is take this equation and rearrange it to have y in terms of x, and then we could go back into the equations that we had before. In this case, we're going to use the second equation, and now we have something that is only in one variable, x. So x squared, a negative 4 where we had the 4xy, and then 4 over x for the y squared part, since y equals 4 over x. And solving this, of course, first thing we would do is get rid of our fraction, multiply everybody by x squared to have that equation, and then we could solve that. Even though it's x to the fourth, that is factorable. It factors into x squared minus 2, x squared minus 8. We can then solve both of those. This one will give us plus or minus root 2. This one will give us plus or minus 2 root 2 when we solve for x. Now, just as occasionally before, just because we found x doesn't mean we're done. We need to then go find out what the y would be for each one of those x's. And so depending, we could either get y is plus or minus 2 root 2 for the x equals plus or minus root 2, or in this case we'll get plus or minus root 2 for when the x is plus or minus 2 root 2. And so our solution set in this case is actually 4 points where these two curves intersect. 4 different points. So that is a way of using the elimination method. Of course, there was also some substitution in there as well. So let's look at a couple of more examples. And oh yeah, remember to check your solutions, because sometimes when you go ahead and plug them back in, especially if you are having to square things and then square root things later on, you may have solutions that are not going to actually pan out. So let us look at this one here. Note that we already have plus y squared and minus y squared, so if we just add these two equations together, we will get rid of our y squareds. And so if we do that, we have 3x squared equals 12, which of course, divide both sides by the 3. We now have x squared equals 4, and therefore x equals plus or minus 2. Please note, another way of looking at that is x squared minus 4 equals 0. That's difference of two squares, or anytime you square root both sides, you're supposed to do the plus or minus. So now that I have my x's, I can go find my y's. And so, let's see, I have the plus 2 squared plus y squared equals 4. Well, that's going to give me 4. I got 4 over there, so that says then that y is going to equal 0. And if I do the negative 2 squared plus y squared equals 4, that's also going to give me y equals 0. And so in this case, my solution set is 2, 0, and negative 2, 0. And I have 2 points of intersection between those two curves. So, a very simple elimination type process. Alright, so let's see. Here I have x squared, 4x squared, y squared, 3y squared. So one solution I can do is I can take everybody here and go times negative 3. I have decided to get rid of my y squareds. So that will give me negative 3x squared minus 3y squared equals negative 15. And then the other equation, 4x squared plus 3y squared equals 11. We have a negative 3y squared and a positive 3y squared, so those will cancel out. 4 minus the 3, I'm going to have x squared, and over here I'm going to have negative 4. And that will lead to x equals plus or minus 2i. Because with the negative there, we're going to get a square root of negative 4. The negative 1 gives me the I. Okay, so now let's go ahead and plug these back in. And we'll start off with positive 2i squared plus y squared equals 5. So note how with this we have plugged it into the top equation. And again, I usually just pick the one that has the smaller numbers. That makes it easier. So this will give me negative 4, of course, because that's what I did over here. Negative 4 was square rooted, so squared it back to my negative 4. Move the negative 4 to the other side, and I have y squared equals 9, and that will give me then y equals plus or minus 3. If I have negative 2i squared plus the y squared equals 5, that will also, because the negative sign will just get squared, so that'll go to, this will still go to negative 4i, so I'm still back to 9, and that'll give me y equals plus or minus 3 again. So both of them have two y values to go with them. Now, let's go ahead and check our work here. If I take the negative 4 into the bottom equation, 4 times negative 4 plus 3y squared equals 11. Again, it's just, that's x squared, so that's x squared, so it's the same negative 4. This gives me 3y squared will equal 27. This will be negative 16. Move it to the other side. 11 and 16 gives me the 27. Divide both sides by the 3. So y squared again equals 9, and that gives me our y equals plus or minus 3. So you can see that it didn't matter which equation I used, I could still get the plus or minus 3 for the y values. So in this case, my solution will be 2i, 3, and then 2i, negative 3, and then negative 2i, 3, and finally negative 2i and negative 3. So there I have 4 connections between the two curves. This one, just so you know, this one would be kind of like a circle. On the other hand, this one is more like an ellipse. And so you could imagine a situation in which, let's see, one of them would be like this, and the other one is more like that. And so you can see how they would intersect at 4 different spots. All right. Okay, we have a word problem here. A box with an open top has a square base and 4 sides of equal height. The volume of the box is 75 cubic inches, and the surface area is 85 square inches, or inches squared. Find the dimensions of the box. Okay, now, very often in problems like this involving geometry, you might need to look some things up because the problem in the book wouldn't actually necessarily tell you. So just as a reminder, first off, for volume, that is length times width times height, which is going to be 75. Now, since this is a square base, that means all the sides are equal. If we will, let's go ahead and just say the length and width are x. So length times width would be x squared, and we're going to use y for the height, and then that will equal 75. So we made that an x, that an x, and that a y to make that happen. Now, we also have an area. An area, of course, that's length times width. And again, this would be for the surface area. Now, for the base, of course, since we've said this is x and this is y, well, it's a square box, so they're both x, so that would just be a equals x squared. However, for the sides, that's basically our height is the y. So for the sides, it's going to be a equals xy, and of course there are 4 of them. And again, this is a side at the base, and this is our height. So that means then our total area, the base and 4 of these, our total area will equal the base, x squared, plus 4 sides, so 4xy, and of course that is our 85. And so now we have our 2 equations. X squared y is 75, and x squared plus 4xy equals 85. So let's take this one and change it around so that y equals 75 over x squared. And then we're going to do that substitution into the other equation. So what was x squared, plus 4xy equals 85 will now become x squared plus 4x, and then we're going to have that, let's divide there, 75 over x squared equals 85. Now, we have divided by x squared, and here's an x, so basically that will cancel with that part there, and that, and then we want to get rid of this fraction, so let's multiply everybody by x to get rid of that x down there. So then that means the x squared will go to x cubed. Now again, this is 4 times 75, so that's 300. Since we multiplied by the x, we got rid of the 1x that was still down there, and then on the other side we will have 85x. Or if we want, we can change this into x cubed minus 85x plus 300 equals 0. Now, we could go back to what we did in an earlier chapter, and this one has ones. Remember the p's and q's that we looked at before, and 300 has a number of factors, of which 5 is one of them. So 5 is a factor. We can check real quick. If we did 5 cubed, that part would be 125. Then if we did 85 times 5, that would be subtract 425 plus 300, and so that would give us 0, and that does make sense, and that's with x equaling 5. So that is one of our factors. Again, going back to those p's and q's, we look at all the factors for 300. So obviously 30 and 10 and and then 6 and 5 and 5 and 2 and so forth, all the different factors possible, and that's one of them that would work. So now we can do a little bit of long division to see if we can simplify this problem just a little bit. And so we'll have x cubed subtract 0x squared. Remember, we always have to fill in the missing degrees. Subtract 85x plus 300. We don't have to, it doesn't matter whether that's plus or minus since it's a 0. Okay, and so we're going to do our long division here to see what we would come up with. And so first off, we need an x squared, since x squared times x would give us our x cubed, and then minus 5x squared. And then of course we're going to subtract that. The x cubes will go away, and I'll be left with 5x squared, negative 5x squared, and then bring down the 85x there. And so now I need a 5x. And so I would have 5x squared, and then subtract 5 times 5, that's 25x. And again, we're going to do the long division. The 5x squareds go away, and I have negative 85, subtract, so that's plus 25, so that's going to give me 60x, a negative 60x, plus 300, and so I need a negative 60. And negative 60 times the x will give me negative 60x. Negative 60 times the negative 5 will give me 300. And so it'll match that. I won't have any remainder. So x subtract 5 does go into this evenly, and I get x squared plus 5x subtract 60. Okay, so next I want to work on this. That is probably not factorable. Let's see, 15 and 4, that's 11 apart, that won't work. Remember, when we have a negative sign here, that means one is positive, one is negative, so we're looking for the difference in two factors of 60. 20 and 3, that's 17 apart. 10 and 6, that's 4 apart. 30 and 2, well, that's too far apart. And 15 and 4, that's 11. Let's see, I don't think there's any other ones, so it's not factorable. So what we can look at now is thinking in terms of using quadratic. And so we'll have A is 1, B is 5, C is 60. And so x will equal negative 5 plus or minus the square root of 5 squared, so 25, minus 4ac. So 4 times 1 times 60. Actually, that's a negative 60. So got to keep that sign straight. So that's going to add up to actually a plus. 4 times 5, that's 20, times 60. 4 times 1, excuse me. 4 times 1 times 60, so that's 240. And then that'll all be over 2. So, let's see, 25 and 240. 25 and 240 is 265. That is not a square, but that's okay. In a lot of these problems, they'll tell you have them be to the tens place or the hundredths place. So let's go ahead and square root that. And let's see. Oh, and we actually, the square root of 265 is 16. But please note, we can't use the negative, because if this is negative and that's negative, then the whole thing's negative. And since it represents the side of a box, that's not going to work. So we're going to have negative 5 plus our 16.2. So again, the square root of that. So we're going to have negative 5. So x will equal negative 5 plus the square root of 265. And all of that is over 2. And let's see. That's 5 divided by 2. And basically that gives us 5.64. And again, we're not going to have the negative case because it's supposed to represent the side of the box, and a box can't be negative. All right, so now that we have that, I can turn around and go, okay, let's find our y. So y will equal 75 over the x squared, so 5.64 squared. And it turns out that'll give me 2.36. If the x equals 5 from that first factor that we had before, then that means y will equal 75 over 5 squared, which is 3. And so my possible answers are either 5, 3 or 5.64, 2.36. So definitely one problem to combine a lot of different sections that we've looked at over the semester so far. And that is section 5.5.